Sound check. Hello world. My name is Stefan Pölz, aka the Flashover, and I am back writing a benchmarking library for C Roslyn components. So let's have a brief follow-up from the previous sessions, because 2 sessions ago we have added to a template pack which includes both a template for iSource generator and incremental generator. We added both benchmarking and profiling to that template, and I have now released that template. It's rather new, and so this now contains, if we have a brief look at it. Actually, let's have a look at the NuGet Package Explorer. We see here the template, and it now has a benchmarking project and also an example project which serves as an entry point for profiling. And I'm mentioning this because this template will be basically the entry point for one of my next conference talks, which is the Update Conference. Update Conference is in Prague from 10th to 11th of November, and I will be building live a incremental source generator with Roslyn, and I will be starting with this very template. And not entirely sure yet, but I think I will prepare like 3 different generators, and then let the audience choose which one then to build live from the ground up. And another announcement is on Tuesday, 16th of August, so in 2 days, the .NET Devs AT, or .NET Devs AT, are having another .NET meetup in Vienna. This time we will be doing lightning talks. So if you are in Vienna and want to listen live to lightning talks, or potentially even give yourself a lightning talk is a short session for up to 10 minutes, then either message us. You will find the link here. I will post the link to the meetup in the chat. Either message us or just go there and have your talk ready and talk with us in the beginning before the event starts. But also, if you're not in Vienna, not close by, you can also listen to the event. As always, we are both streaming on Twitch. We are streaming on both Twitch and YouTube as well. You will have the links in the meetup page. So much for announcements. So let's come back to the follow-up part of our previous session. Previously, we have continued, so last week, building the benchmarking components for diagnostic analyzers. Since then, I have refactored the solution a little bit, which I want to show you right now, and while at it also show what we got so far. So what I actually changed is the tests. So previously we had a diagnostic which got reported when there is a dynamic parameter in use. I switched that to the example that is also present in the Roslyn SDK. So if I go to Roslyn SDK on GitHub, we can go to source, SDK. There is a template. Is it in Roslyn SDK? Yes, a project template, a C# project template for diagnostics. And this contains an analyzer. And I've switched the example analyzer to this analyzer, which is basically registering itself on every type, so on every named type, and checking if it contains any lowercase character, if the type name contains any lowercase character. And if it does, this reports a diagnostic. What this example also has is a code fix. This code fix now provides a fix for this diagnostic and basically gets the identifier of this type and changes it to all uppercase. And then here is some code to update the document and also update the entire solution, because this type may be in use already, so we can rename this symbol in the entire solution. But this will be, we will then also use this for the next component when we actually do the code fix. But I wanted to base it on this example. And if we have a look at the tests, we will see exactly what this analyzer is doing. So we expect here a diagnostic because it contains the type name. It's a class, could also be a struct, contains lowercase characters. And if we invoke the fix, so first of all, we have a diagnostic. We see this here, and it gets reported here with location 0. The argument is type name. And if we apply the fixer, so in Visual Studio, this will be control dot, or in Writer, this would be alt enter, or in ReSharper. Then the type name from lower, which may contain lowercase character, now goes to all uppercase. But so that the fix part, this will be potentially next session. In this session, I show the example via this analyzer. So basically implemented it. We have two rules. We have one rule from the template, but also an additional rule that we also did last time, because we also report diagnostics from additional files. So you have a separate rule for that. And we register a symbol action on the name type. So this is very similar to what's on the GitHub repo for Microsoft. And we also register an additional file action. So for the symbol, for the I-named symbol, we report a diagnostic if there is any lowercase characters. So this is pretty much as with the solution on GitHub. However, I added two things, what we were set out to do today actually, but I did it off stream because it was not that big. Adding both properties and also tags. So both rules now have a tag as well. This was missing last time, I added it. And we can also add properties to a diagnostic that we create. So here they are. And they are actually a combination of key value pairs, or better to say name value pairs, which then get passed to a fixer which registers for this diagnostic to fix it. So the diagnostic could give additional information that the fixer then could use in order to how to fix too. So it knows additional info how to fix this issue. In this case, we say it's an error. And for the additional file, we basically read the file and then very similarly also create a diagnostic. Here we have now a create location method because in the additional file, we have no location, there are no tokens, it's an additional file, it's not a C# file, so there is no syntax tree, there are no tokens, there are no nodes, so we don't have a location of a specific node in this tree, but we create the location ourselves. What I assume here is that this additional file only has a single line. We grab that line and then, yeah, basically start at line number, which is 0 in that case. I could have hard-coded it as well. And start at this column and at this column. And this is how we create the manual location, where we also have the file path of this diagnostic. We will see, naturally, let's have a look at the benchmarking component, which handles this. So I have here something called order diagnostic. I will come to the order in a second, but basically what we have, if the diagnostic has the allocation of kind source file, it's a C# or a Visual Basic file, so it has a syntax tree. The syntax tree is not null. But if the diagnostic in this case is an external file, so this would be the additional file, there is no syntax tree, we can debug assert that the syntax tree is null. Yeah, so that's the analyzer. Now let's actually go through the component that we have so far. We, as always, have an initialization phase where we set up all we need. So we create an options provider. This may not be working yet. We are set out to implement this also in this stream today. This is one of the to-dos. We create a compilation, create the analyzer options, and for the invocation, this is what the benchmark should invoke plenty of times in order to generate a benchmark and benchmark statistics. Where we set this analyzer with the options and get the result, which then invokes the analyzer actually. And in the inspection phase, we do a bit of tests and see whether this diagnostic or those diagnostics are actually those that we expect, to give a brief hint about if that benchmark is actually doing what we expect it to do. Here I invoke this order diagnostic. We will come to that. Why do we have to order them in a second? All right. Let's also have a look at the tests. We see there is a red test. Let's run these. I ran them previously. They were green, but now they're red. This one is actually a flaky test, but we will come to that when in a minute. So I haven't changed all too much at the tests here actually, other than this test is now, we pass in here a C# file, which has where we expect the diagnostic here, because this is a class, a type name. This is not a class, but it's a type name which contains lowercase characters. We also have some additional sources where we have 2 additional sources, 2 structs, which also have lowercase type names, and the additional texts where we have like path1, path2, path3.txt, and we expect the entire text to be reported a diagnostic on. We also set some C# parse options. This will come in, we will need this later. Or some compilation options, metadata references, we're all going to need this later. And yeah, the analyze options, this is a to-do for today. And then we invoke, and then we inspect and see if those diagnostics actually get reported. So we have here this markup location that we see here in the syntax indicates the location that we then basically set here. I have two methods, a create diagnostic and the additional diagnostic, where the regular diagnostic is the ID 001 that we also built last time, and the additional diagnostic down here we also built last time. I just refactored this into methods because they are always pretty much the same, other than the markup location, the message argument that we pass in, and I also have an additional location. So when we have a brief look at the analyzer again, we see that for both diagnostics, we pass in an array with the same location. It's the same location again, but we pass it as additional location so that we can check, because a diagnostic could also have additional locations, but they're optional. So we want to verify them as well, both for the additional file diagnostic, but also for the type contains lowercase characters diagnostic here as well, location and an additional location. Okay, does this explain the test pretty much? Pretty much, yeah. So we pass in the additional location, and this is basically the start character and the end character. So when we go here, if we would count 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 and we go on and go on, come to here, this would be the this would be the 95th character. Then we have 1, 2, 3, 4, 5, 6, 7 characters, and are then at the 66th character. So this is the additional location, but it's actually the same location. Okay, so much for the follow-up. Manuel Zelenka says, good morning. Always lovely to watch the stream on Sundays. It's always lovely having you live on the stream as well. I'm glad you made it to tune in. Okay, before we jump back to the code, let's have a look at what we want to do today. Okay, I should have refreshed the page, I guess. Yes, there we are. So we accomplished the follow-up, and today perhaps we can finish it actually. At least we continue, but most likely we'll finish implementation of the analyzer types. So first of all, I want to inspect what's up with this order, and there's actually still a bug that I want to fix. Then I would like to assert the analyzer options. We will use the properties for them, and I also would like to assert the C# compilation, because those are both inputs to the analyzer in order to check that those inputs get correctly set by the benchmark. And optionally, at the end of last stream, we also had this as an option, if we have time, if it makes sense. Instead of the analyzer options, use compilation with analyzer options. But let's see what's up with the order of the diagnostics. So this is what I didn't know last time, and I also didn't encounter because we didn't have any additional sources, and also no addition. We did have additional text, but we didn't have any additional sources. So here now I have actually 3 source files. So there's 3 source trees, and if we run this analyzer or the benchmark, I had a flaky test, because the order was always different. Sometimes it was this diagnostic which got reported first. Sometimes it was this which got reported first. Sometimes it was this which got reported first. And this is why I had to include ordering. So if we now jump to the order diagnostic method, so this is in the inspection phase, where we get from the result. So this is actually what the generator reports, all the diagnostics. But we want to order them to be in the same order as we actually created the syntax trees. Our order in the test is, we have first this source, which should be this diagnostic. Then we expect this diagnostic from the second source tree, and then this diagnostic from the third source tree. And the order is different because the analyzer in question actually has enable concurrent execution, which means that those callbacks that we register here, so the initialize itself is not concurrently, because this is only executed once per analyzer 1. But this action that we register here is now executed multiple times. For example, this symbol action is registered for each and every named type. This additional file action is invoked for each, or executed for each and every additional file. And they may run concurrently. And I wasn't really aware of that, that this is now, so this is why we actually also had to, we did this last time, had the executions that we count, because we expect for each named type that we have this action to be invoked once. Actually, we have to have an interlocked increment here. Otherwise, those numbers may be wrong. Maybe not, but perhaps they would be, because this symbol, this analyze symbol is potentially executed concurrently. So what's now up with this flaky test? I will copy the error message into a VS Code instance. We'll run the test again and copy the next output as well. And I will now compare those two outputs. And we see in the previous one, we had additional text 2, but in the one before we had additional text 3. So this is already flaky, and if I run it sometimes again, perhaps it passes. Let's get it to green one time. One more time. I actually got it green before I started the stream once. Okay, don't get it green now, but here we have some flakiness because this this additional file diagnostic, where we report on the entire additional file, is executed concurrently. So we actually don't know which one is executed first, which one is executed second, which one is executed third from these 3 additional files that we pass here. So we have 1, 2, and 3 additional files. So now I would like to do the ordering. I want to order the diagnostics in the same order that the test declared them. So in our case, we know that the first file is called path1, we have a path2 and a path3. So I would like to order these, I hope I can get to this actually, and order these by that input. I hope this actually works. I'm not sure. Let's go to the benchmark. So we have the order diagnostic, and here I filter all the external files, because first I filter all the source files. And actually, what we do for the source files, let's have a look at this. So our first source file that which register is this one. Then this is our additional file, our additional source. This is the second one, and this is the third one. So each of these is one syntax tree. And our compilation that we have still has the syntax tree. So this is basically the input compilation before the analyzer runs actually. And we now iterate the syntax tree in the original order and check if the diagnostics that get reported from the analyzer actually is a source file location, or has a source file location, which means it's actually a C#. So there is actually a syntax tree. Then we check if it's that syntax tree in order. And this is how we can order. Perhaps maybe there is a nicer way. But it does the trick. So we now have actually, perhaps let's debug it so we see the effect. So as our input diagnostics should be 6, indeed, we have 6 input diagnostics. First, we have the mystruct1, which is from the second file. Then we have the myClass, which is from the first file, and mystruct2, which is from the third file. And when I run the test again, the order may be different. And I know that the myClass is from the first syntax tree that I registered. This is from the second syntax tree, and this is from the third syntax tree. So after now sorting, they should be in order. Yes, first myClass, then mystruct1, mystruct2. This comes from the source property, and this is the first entry in the additional sources, and this is the second entry in the additional sources. Okay, and now we need to do the same thing for an equivalent thing for the external sources. If we again jump to the sources, this is what we get as a result from the analyzer. We first have, okay, now we are accidentally in order. 1, 2, 3. So that's great. If I would continue this test run, now it would turn green. There it is. Perhaps I should I choose a different color? I like green. Today is green day. So let me run it again, that we actually have it not in order, or not in the expected order. Yes, now we have 3, 2, 1. Now the test would fail. So how can we get them into 1, 2, and 3? So this is, let's see, this diagnostic, what does it have? We have a location, scripture ID. So we must use the location, but this may be a problem because the location has no property. Well, the toString, perhaps from the toString we know, but it actually doesn't say where it is. I am inspecting the wrong location. Let's jump on. This is also a source location. This one is an additional location. So let's have a look at this diagnostic. So we see the location is an external file location. Let's perhaps jump to this type. It's in Microsoft Code Analysis external file location. Let's jump to my second most favorite site. My most favorite site is source.net, where we have the source code of the BCL. And my second favorite site is source Roslyn.io, where we have, it's the equivalent, but so it's the Roslyn source code browser. And let's have a look at the external file, and this is what I was afraid of, that this thing is internal. So we can't really get to the file path. Do I need to do reflection? I would like to avoid reflection, but perhaps we need to do reflection here. I don't like. The problem is if this changes, because analyzers, let's have actually a look at location. If we go to Microsoft Components.location, the base type is available since Roslyn 3. So there's a lot of versions. What if it has changed in one? What well, I thought it, but this would be not so good. I would need to, in worst case then, if there was a change, then need to know, okay, which version is it, and then have like a switch to do the right thing on the right version. But perhaps there is a different way. The location, because the base location, which is public, does have a syntax tree, but this one is null in this case, is in source and is in metadata. Don't really do much for us here. I'll zoom in a little bit. We have a source span, which is a text span, but I doubt that this has like a file path or something. No. This is a start and end, a length. What else do we have? File line position span. Ooh, there's a path. Perhaps this helps. Perhaps this helps. I will browse what else we have. Nothing else here could help us. So perhaps it's the file line position span. Okay, what else do we have? We have get mapped line span. What's the difference between get line span and get mapped line span? Gets the location in terms of a path, line, and column. Gets the location in terms of path, line, and column after applying source line mapping directives. Oh, that's the line thing. This has actually been expanded on C#10. C#10. That this line preprocessor directive actually has an enhancement. I haven't used it, so I totally forgot about this. But it doesn't really matter now. So this has been improved in C#10. And if we use this, okay, so this is the get line span is the actual one, and the get mapped line span is what the user or the author wants it to be. So we can actually change the line. I'm not sure if we should use the line span or the mapped line span, but if we only want the path, then perhaps it doesn't matter. Okay. I never knew how like this hash line was implemented. I guess it was right there. Cool. What else do we have? We have equals, toString, equality operators, debugger display, static members. No, so it's one of these. Now I want to have a look at how this is actually implemented in the external file location. Okay, so the external excuse me. So the external file location actually doesn't make a difference between the line span and the mapped line span. So it doesn't really matter. But I would assume that I think it's a source file location. It's not. What's the other location? Also, am I still debugging? Yes, I am. So I could have a look at it actually. No. Oh, I'm in different context here. Uh-oh. So what is the implementation, the derived location of a source file, which has a syntax tree? It's no, that's a diagnostic. I need the location. There it is. It's source location. Okay, not source file location, but source location. Source location, there it is. So how is the file? So there, now I expect a difference between the line span and the get mapped line span. Okay, so the syntax, this is now what the syntax tree does, I guess. So this is again abstract, now it depends on the implementation of the syntax tree. Okay. Okay, so, but we saw for the external file location, there is no difference, so let's get the get line span. Cool. Okay. So we filter all. Sorry, this key. All the diagnostics which our external file. We now can say, basically very similar to what we do up here. We can get the line span. No, we can't. Oh, no, it's of course on the location. Get, not the mapped line span, but the line span. Wouldn't make any difference for the implementation of an external file. Yeah, because that makes sense why it doesn't make any difference. Because, oops, this hash line is a C# feature. So it only makes sense in C# files or in source files. It doesn't make sense in additional files. They don't know how to interpret it. It could be XML, doesn't make any, or yeah, text file. Okay, so we get the line span. This is a file line position span. I just call it line span, like the method indicates. Okay, and this line span now has a path. That's cool. Let's have a look what this path actually yields. Debug the test. It should have like path1.txt, path2.txt, or path3.txt, I hope. And it is. Yoo-hoo! Cool. So we can determine this by using that. Okay. That means we need to iterate. We'll do it very similar that we do up here. I'm not sure if this, perhaps there's a nicer method of sorting them, but this is what I briefly come up with. So we have, okay, compilation. We start a compilation, but we do not have the, yes we do. Yes we do, no we don't. From the context, okay. I need to pass in the inspection context as well. Let's forward the inspection context, because the inspection context now may have, oh no, that's not on the inspection context, that's on the initialization context. Okay, so that means I don't want to store the entire initialization context, but I will keep a, okay, let me revert that. We don't pass in the context, but when we, in the initialization part, somewhere we are doing something with additional texts already. Create compilation, I guess down here. Okay. So let's store them actually. Let's say context dot additional texts. They are in iCollection I only need the paths, but I stored the entire collection. No, perhaps I only really get the paths. Let's say select. Can make a static mapping function additional text dot path. So we select these, and then we can say what's that? That's to array them. To immutable array. That's more Roslyn like. And we now have, I called it additional paths. So let's create a field for the additional paths. Okay. Let's format this a little bit more nicely. And now we can use the additional paths. These are just strings. So we have an additional path. And now we iterate through all. Okay, well, perhaps I should split them, but this is optimization for later on because I iterate the whole diagnostics that the analyzer is reporting twice, but filtering difference. So iterating it twice, but only grabbing, like in this test case, half of it each. Yeah, but that would be a smaller optimization to only do this once. So for every diagnostic, if we now don't return true unconditionally, but if the line span path is the same, let's do a string equals from the additional path. We get a warning. Okay, now we have a warning, but only on in net core 3. We get the warning because there is a string comparison overload, but in net standard 2.0, this overload does exist as well. Cool. So let's say string comparison dot ordinal. Yes. I guess there's a default anyway, but I like explicitness. Okay, and then we add these. They need to be in scope to the collection. And now I guess we sorted with diagnostics from the additional files in the same order as the additional files are declared or added to the context in the first place. So let's have a look at the input diagnostics. We get, so the order is totally scrambled. We have, so this is the second file, first file, third file, also the C# files. And here we have, here it says 231. This should be, of course, 123. And when we apply the sorting, now the sorted collection is C# style in order, but also the additional texts. Yes! First success of today, which now actually should make this test pass. I will run it a couple of times. I will run all the tests of this type a couple of times, maybe 5 times, to see if they are stable. I also have some debug asserts here to ensure that I accounted for all the sorting, that I didn't forget any, so that the output collection still has the same length, and doing an intersect to also eliminate potential duplicates if we like added one twice but forgot one. So to have this correct. Execute it 3 times, so number 4 and number 5. Those are the tests for net 6. Let's also run the tests for net 7 for net 472. So that's .NET Framework. And they're also green. Cool. So we have fixed the first issue. Now I'm running all the tests again, so I expect them to be green. What I would like to do now is to make this test more... If the ordering, because in here I have like one type per file. What if I would add a second one? So I call this my class 0. And let's create a second one, my class 1. Let's actually create a third one, my class 2. And I also wanna, now I need to increment those markup locations because they are not the same location. Perhaps in this one I also want to add a second one. So I'm adding a second struct here. So this will be number 3. I call it my struct 3. Number 4, my struct 4. And here's number 5. Okay, where this is now number 6, number 7, and number 8. I want to go to 9, so I will add one more 8, 7, add here an additional struct, which will be number 6. So we now have 10 diagnostics. Okay, so let's adapt these as well. 2 and okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. The location here hasn't changed, but the my class, these locations now have changed. So this is 0, 1, 2, 3, 4, 5, 6. Okay, so the additional location is the actual location. Since we added one character here, this should be incremented. Actually, let's see the test fail first. Fails. Because I assume the location is wrong. Yes, so here. So let's fix the additional locations. Since for the my class we basically added one character, so the end is not 66 but 67. Okay, but what about the rest? I will copy the string to Notepad, to VS Code. I remove the markup syntax because this is what the setup code does as well, because this would be invalid C#. And now we can see that we started 95 and end at 67. Okay. What about this one? It starts at 93 and ends at character number 101. And the last one starts at 127 and ends at 131. 5. Okay. Now for the MyStructs, I guess for the MyStruct 3, nothing just changed because we just changed an we changed this from a 1 to a 3, so the first one is fine, but the second one, I do again the same. I copy in the string, but remove the query syntax. I basically sanitize it, and my struct 4 starts at position 28 and ends at position 37. 37, 28. So that's my struct 4, 28, 37, and the same for the 6 as well, because these two additional files are quite the same, the only difference in number. Okay, I think I made them. Is it as 26 or 28? Okay, need to check again. 28, 37, so it's 28. Okay, and the rest shouldn't have changed, so I now added, now there is more than just one diagnostic which gets created per file, so I would now hope that the tests still pass. No, they don't. Because I expect my class 0 but find my class 1. Okay, I would assume the ordering is wrong again. So that means it only worked. Okay, so within one source file, they may also be out of order. I'm not sure how to fix that. Well, I could order them by location, perhaps. Oops. Oh, let's have a look. There is a. Yes. There's actually, isn't there? No. Enumerable visualizer. Yes. Ooh, dark film. Yeah. So the order is incorrect. So the order is within the files. They are correct. So we have like 1, 2, 3 grouped, 3 and 4 grouped, 5 and 6 grouped, but within one file they are wrong. So how could we sort these? Maybe we need to order them now. So we filter them here. Now let's also order them. Okay, order by. Fun fact? No, it's not a fun fact. It's just a fact. .NET 7 will have a new overload or a new method which is called just order. And so if you want to order by itself, then you don't need to write like itself goes to itself. You can just write order. So this will be coming in .NET 7. I think it's now released in the previous 7, which has been published recently. Okay, but we want to order by. Let's grab that. I want to start it with a static, and this diagnostic location dot. Can we order by the location? No, the location is not. Oops, yeah, I'm doing wrong. I want to put it here, of course, yeah. Is the location, no, location location is no. Perhaps the, what do we have? Let's see what we have at the location. Ah, come on, Visual Studio. We have syntax tree, text span. Text span sounds promising. Ah. Text span is eye comparable. That's great. Okay, so let's use the text span. So we have location.text. No text span, just span. So span. Okay. Okay. Does it turn green? It does. That's cool. But I may have the same issue also with additional files. So, okay, I now will remove one struct here again, the number 6. So the number 6 is gone here. However, I do make a new additional file. Okay, so perhaps at the first additional file, we will add a second line. Okay. So let's make that a, okay, this gets a bit difficult to read now. Let's format it a bit more nicely so we know it's more, so that it's more apparent about what is added. So we see we have 2 additional sources, and it becomes apparent that we have 3 additional texts. And one of these additional texts, let's do the first one, should also have another line. So I will copy this, we'll make here a 6. Now I make this a, I could make it a, I just do string concatenation. Environment dot new line and a second, string, a second line. Okay, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So we expect now the 7. Okay, so this should be, I also named them accordingly. So we have additional text 6, 7, 8, 9, 6, 7, 8, 9. Okay. But how does this actually look like? What can we expect? Let's again manually sanitize the string. So the second line starts at 19 and ends at 36. I will make a mistake here just to see it failing. Okay, and now let's run the test. Because I actually expect the same issue, that there is some ordering. So this one should be flaky. Oi, debug failed. Solid 8 diagnosis, but found 9. Oh, yes, yes. Okay, I expect 9 diagnostics, but I need now to change the analyzer, because the analyzer that we use for testing only creates 1 location per line. So let's call this locations. This should now return an enumerable of location. Turns into locations. And then we, for each the locations, and for each location we create and report a diagnostic. Okay, so we pass in the file path and the source text. Okay, we can no longer assert this, there is only one. We now actually have to for each over the lines. And return one location per line. Yield return. Oops. Yield return. Okay, so let's see if the code is actually still correct. So the start is the line number. Text line start. I'm actually not sure. Let's see if this looks good. Okay, so the start is 00 on the first line. And 017. Yes, that's what we expect. Because line number is 0. If I F5, we are now, because we had two lines here, on the second line, where the line number is now 1. And we start at 19 and end at 36. This is what we saw previously. So this looks actually good. But I expect the test to fail because I did some I added one additional. Okay. The text is wrong. Because I add the entire text to that. This is not. How can I get the text of just one line? Can I toString this? Or do I need to split? I could also split if I cannot toString the line. I can. Okay. So I should create location. But now, so we return not only the location, but also, okay, so this text, we can't use this text here. But it should also have is this then still a location? I call it extract lines. Well, we don't really extract. I call it get lines. And a line is a value tuple of a location and text, string text. Okay, let's do the same here. So it's an enumerable of location and its text. Okay, so we say yield return the location, but also, or we just, no, yeah, but also the text line dot toString. Okay, so of course, let's do a var and then this doesn't. Okay, let's call this lines. and one line is a location and text. Okay. And we now have the, actually could do deconstruction. Yes. So we can say, but perhaps I keep it non-constructed. Line.location. We also put that here. And the text. Line.text. Okay. So this may work. Okay, I guess this is not because of the error that I intended. Yeah, we are off by 1. So if I fix this error, now should be green. Cool. I will again run it 5 times. So that's number 2, number 3, number 4, and number 5. So that looks good. Cool. Cool. Perhaps just to make the test more likely to fail, let's actually make just 2. So I will have a file path 0 and a file path 1. And I move this one also to the second one. Yes, so that we have 2, so the test is just more likely to fail. In case there is indeed an error. Environment.newline. But I actually, no, I still want to have, I'm indecisive. Let's have, I still want to have 1 with just 1, just to see that 1 also works. So I will have 2 paths. 1 with 3. And 1 with just 1. Yeah, this is how I would like it to have. So there is just a singular case also working. Okay, well, perhaps we should also add one which doesn't have a diagnostic. I'll just put it an empty string, call it path2. Perhaps we should also verify that. Okay. 1, 0, 1, 2. Okay, now I call it 1, 2, 3. What has changed? Number 8 now has a different location, of course. So I will, oops, I forgot an environment new line. Okay. So we report here per line. I will sanitize the string manually again. So the 8th line starts at 38 and ends at 55. Okay. And yeah, but here is no text, which means I should in the Let's do a select. Text line collection. Okay, so that's a line, but what if the type is not apparent, I like to. It's a text line. Well, okay. Well, we do see it here, but still, text line. And if the line, oh, I would toString twice here. No, I don't like that. I don't like that. So I will just say if. I will move the toString up here. Call it string text. And say string.isText null or empty, null or white space. So let's make that text a white space. Okay, and if it is null or white space, just return. Continue, of course. Yield, continue, yes. And okay, and then we of course want to pass the text here. So now we only report if there actually is some text. And okay, I'm not so super sure if this text test is now, if this adds some value, but yeah, why not? Okay, I will run it 4 more times, 3 more times, 2 more times, and 1 more time. That looks stable. I'll also run the .NET Framework version of the tests. Or the .NET Framework target, better to say. And let's run all of the tests. Okay, cool. Cool. So we have fixed the order and stuff. So orders of diagnostics. I guess that's cool because we considered, yeah, so there are multiples and they need to be in order, both sources and additional texts. Cool. Now to the next part, analyzer options. So I have this ready already. If I add some analyzer options, I believe one of my tests will fail because I have an error somewhere. But this is all I know. Now I need to figure it out where the error is and fix it. Yes. There we have our failing test. It says unexpected diagnostics. Unexpected now. We expected 10 diagnostics, but had actually 4. Why is the analyzer options changing that? Does this make sense? I would claim to say no. We only have 4. Oh no, hold on. Oh, okay, what's the problem? We only have the additional error ID 002. So that's the warnings from the, or the errors from the diagnostics from the additional files. Where are the diagnostics from the source file? Because there should be 6. 1, 2, 3, 4, 5, 6. Yes. Barely. So if I add this, something is wrong with the options. Perhaps if I debug the test, maybe I see an exception or something. I do. Call stack is little. That means I guess the analyzers. Okay. So this is the ad hoc config options provider that we have implemented for the generators? Yes, but and the generators use like this global options. However, the diagnostic analyzers, they seem to use this get options here, so I need to implement that. Okay. Well, I guess the simple thing would be just to return the options, right? Perhaps you need to do something with the syntax tree, but well, we can always add some logic later on. That passes already. Okay, but we are not really considering them just yet. So I want the analyzer options actually have an influence, and for that I would like to use this properties, the property bag. So here we will add some information from the analyzer options. So let's see. We can get a hold of the options from the context. So now we are at the analyzer, and let's see, we can say context.options. And let's hope we can get there something, because if we have a look at the test, I want to add this config key and this config value. So if we want to test in debug mode, we will hit the breakpoint for the first diagnostic, which is in our case here my class 1. And let's have a look. So the context options, they actually have the additional files. Okay, but we don't care about these because we already checked them. Okay, but what we do care about is the analyzer config options provider. Yeah. And the analyzer config options provider. Okay, I guess this is exactly what we now have, and we can now call the get options with a syntax tree. So we say get options. We have a syntax tree. We should have a syntax tree. So there's with a symbol analysis context. There's a compilation. No, we have no syntax tree. So because we are on the symbol level. Not sure if the symbol has a syntax tree. Declaring syntax, no, it doesn't. Well, let's use the global options flag. And there's a try get value. And we would like to get, oops, where is the test? It's here. We would like to get this value. So we give it the key. So that means it actually is a bool returning method. So if we find this key, I assume it's like a dictionary. Yes, it has a string which is not null when we return true here. Okay, value. And let's add this value to the properties. So I will move this block down there, and I'll say properties. Okay, perhaps a, yeah, don't want to do that. I want to create range. No, let's create a builder. So I have an immutable directory dot builder. Okay. And we say builder dot add. This should take a key value pair. It takes a key value pair. Still like also an overload, which where we can say like with a comma. Oh, there is. Yes, key and value. Okay. And what's the let's actually add what we add from the options. So we get this key here. So let's actually say const. How is this called? This is called key. We pass in the key. And we add key. And if we find it, key value. And then, okay, let's have a look at the definition. Now we need to create the properties from this builder. Properties dot to im properties is builder dot to immutable dictionary. Okay, so this is now an immutable dictionary, and we will set this okay. And use var instead. I want to have the explicit type here. So because it says immutable dictionary. Okay, then let's have var. And let's have a look at the test. I expect now the test to fail because we didn't assert. We asserted still the values that are hard-coded here. So let's have a look if the test is actually failing because of that. Here's a difference. The properties we expected name value. I hard-coded them previously, but they have been indeed those that we set here. So I can actually now expect. So I will grab that and add this to the diagnostic. So the properties now contains these values that we set up. Here. Perhaps, can we make this call? Bit of duplication isn't so all too bad. Okay. This should make the test pass. I will actually inline this here. Yeah, I like that better. Test passes. Okay, cool. Is this already the options? Guess it is. So, because if I go ahead and in the initialization phase, change something here. The test would fail. And if I don't have the key actually, if I say key 1, now the key shouldn't be found, which means that the properties should be empty. Let's see if they are. Yes, they are. Cool. Okay, so I guess that's it. We now assert analyzer options. That means we can actually pass key value pairs options and have the analyzer consume it. Now I would like to see if I pass in the compilation correctly. And I will add some more properties. So, okay, we have here the builder. You know what? I will revert that. I will keep the const here. So, and let's have a look at the compilation. Since we are in C# land here, because yeah, so what I actually did is I had a look at all these context options that diagnostic analyzers support, and I had a look at what comes from external. So I discovered the analyzer options that we now took care of and the compilation. So we will now want to also assert the compilation, because what we actually do, if we have a look at the benchmark, so in the initialization phase, we create a compilation here. And for this compilation, we pass the C# text, we pass additional texts, we do sanitize them from the syntax, from this markup syntax that we saw. And then create eventually a C# compilation out of that. We also use, so we pass the C# tree, we use parse options. Now those parse options contain a language version and so on. And I want to assert these. There's also metadata references, so perhaps we can assert these as well. All right. So we can assume that the compilation, let's do this not in the for loop, let's do this actually up here. Debug.assert, we can assume that the compilation is a C# compilation. Then we can cast it. Unsafe as is not my favorite cast. C# compilation. Okay. And now we can say C# compilation dot. We now have a language version on that. Language version. And I want to add the language version to this properties as well. So I say builder dot add. Language version is of type language version, so the key shall be name of language version, and the value should be the language version. ToString. That's an enum, right? Yes. We just .toString it. Yeah, that's good enough. Okay, and let's see now. Actually, the expected properties of the diagnostic should include the language version as well. So I would assume the test to fail because of that, and it does. But I would expect that this to come first, not second, because I had this first is, well, perhaps the order is this like sorted or something? That surprises me, because when we debug, I don't have expected it to be first. Or I do something wrong with this printout logic. This could also be the case. Yeah, first is language version, then is the key. is this actually happening? Stack trace. That's the exception throw. Oh wow. Okay. So somewhere in this, their properties should be here. So it's the third. So the code that we saw here is, that's the code that, that's the code that then produces this diff string. Like it sees what is equal, and when there is a difference, it does a minus in what was expected and a plus on what was the actual. Okay, so 1, 2, 3. Oh no. Okay, because no. Properties. Oh, okay. Here are the properties. And so because they're I'm not sure why I'm confused right now. Okay, but let's see. We actually do. I do a select. I do a string join and select the. Okay, and what's that? That's actually selecting the properties. So we. Okay, yeah, we wrap them in a key value pair. Okay. Why are they second? Surprises me. Maybe they are sorted by, I assume they are sorted by key. But this is now something that Roslyn does. Unless I have, no, because here are the actual diagnostics and they get in from here. No, okay. So Roslyn does order them. Which means we should also order them correctly. Okay, where's my test? Here's my test. Okay, so the second one should be, we can also do a name of language version. I hope that's a C# language version. It is. And as a second value, what am I thinking about? Language version.c#. Per default, we have 7.3 toString. Okay, again, now to make this more apparent, I will format this as well. So we will see, we expect two. This is analyzer config options. I made a mistake here. I didn't intend to change the analyzer config options. There is only one analyzer config option. But in the expected, yes, so for the diagnostics that we create, the properties here, they should be. Okay, so this is a dictionary, so we have key value. Like so. No, what am I doing wrong? This is too much of a parenthesis. Okay. So the second one should be language version with C# 7.3. Let's run a test. And it passes. But what if it is always C# 3? So actually I want to make a mistake with the compilation. Because in the test we can set C# parse options. Oh no, we actually set it here. Okay. What if I don't have that? What's the default that we have here? I assume, since we depends now on the package that we are package version we are using. Since we are using, let's see, what are we using? So we don't explicitly state it here. That means we get it from the test. So we have 420. I actually should lower this, but that means it should be C# 10. Let's see if this is correct. As we assume C# 10. It is. It is actually C# 10, but we expected 7.3. So what I would like to do is to have like a default. So this is like the explicit test. I set it to C#. What's like the lowest version that we could compile this code? C# 1 perhaps? Let's see if this works. Interesting. Now if I pass in C# 1, then the order is is the order random? That would be not so cool. Why is this now coming first? Well, we do see C# 1, so this is all white, but why is the order different? We actually do a sequence equals, so the order for the assertion does matter. Now it's, is the order not deterministic? Damn it. Is this how the builder works? Excuse me. Well, I guess, it's a dictionary. So dictionary doesn't really have an order, so that does make sense. But I would like to have an order to make the test deterministic. Okay, let's handle this problem afterwards. Let's first close the files we don't need anymore. Expand one test. So I will actually, should I copy? No, I will not copy anything, but I will copy the source here to this test. So we have like here default test where we don't set any special options. I just want to have like a very small test. We add a string here, but we have only one. There is only one type, only one diagnostic. Make this test rather small. Let's create an object initializer here, but let's only set the source. Actually, what's happening here, if I hit Control dot, this is actually did I show this already? A code refactoring that I wrote with a friend of mine. And we built it like 2 years ago. This is when we actually started with Roslyn, and this, what it does, it creates an object initializer. It scans the type for all accessible members. So we have inits here. It's public, so that's cool. And also sees if there is a similarly named local where the type would match. And since this is a string and we have source, but just in lowercase, I think we do a invariant check. Also string, we assign this directly. I believe Rider has very similar thing that Visual Studio didn't have. And back then, when we were colleagues, we were using Visual Studio at the company I've been in. So we wanted to have this as well, so we built it. But we will talk about factorings in, it will be the second to last. Type that we implement. So in like, I don't know, 3, 4, 5 sessions perhaps. Okay, so we just set the source, we invoke, but this test now would fail because we also need to expect some diagnostics. So let's create an object initializer here as well. Okay, diagnostics. Let's grab the first one. So this is a collection. Paste it in. I want to change this to just my class without the 0, which means the 67 comes from 66. The 0 disappears. And now we need to make these two local methods. I actually need to make them member methods. I make both of them member methods. So I will put it at the bottom of the file, a private static method, format it correctly. And the other local function I will also change to a member so that it's in sync private static. All right. Okay, let's go up to the test. The test should now compile, and the test may actually no, it will fail because we now need to make this key value pair a parameter to our test. So let's have a look at the issue. So, okay, so in this case, we don't have the analyzer config set. We only have the language version, yes. And the default is C#10. So I actually should, how do we do that? This one. So should we make the properties a, how could we best make this parameter? Well, let's set the language version, but optionally. So let's say language version nullable is language version, but we set it to default. And I need to cache this diagnostic. And we then say diagnostic.add, no, properties.add, yes, okay. So let's say actually if got this, if the language version that we pass in here has a value, then we actually add to this dictionary name of this here. Then we can make this again a one-liner because it's only one value. Okay. And we add the, if it has a value, we add the language version dot value to string. Okay. So actually we always have it, don't we? Oh, no. Ah, these are optional. Haha, the language version is not optional, but the analyzer config options. Should I add a boolean? Oh, add a boolean. Boolean has config per default to false. And I guess then we don't set the properties here at all, but we say if has config, then diagnostic.properties.add, and I can get rid of this entry here entirely. Okay. And so, now to get it right, we have actually I want to make it here we create a diagnostic. We expect it since the default, we don't set it, we don't override it, the language version, so we have the default, we expect language version.c#10, and I set it to false here explicitly. We have no, I want to make a mistake, see the test fail, if I made the setup correctly. And down there for the expected, here we actually have analyzer config options, so we all expect a true. So we have here, yeah, we set the language version here. So I actually let's set it, where do we set it best? Let's go here. Var language lang version C#1, and we set it here, and we set it all for these diagnostics as well. And eventually the options here are true. How does multi-cursor thing work in Visual Studio? I always mix it up with wider now. Yes, no, I made a mistake. Okay, let's run the tests. No, there is a mistake, Oh, yes, I didn't implement it for this additional. I should, but I'll do this. Should I? Not necessarily, I guess. No, perhaps we should, just to make sure. Okay, so the one test fails, but this is, I guess, the expected failure because, yeah, we didn't set the true correctly. So when I fixed actually false, because there is none. Now let's let the tests run. Now this should pass. However, the second one, this one may be flaky. Yes, it is flaky indeed, because I assume the order isn't right. Yeah, so this looks correct, but the order is incorrect. So if Roslyn is if the order is indeterministic, I should actually make the comparison also non-deterministic, order irrelevant. The order must be irrelevant. Okay, so we can go to the diagnostic here. Okay, and for the properties, okay, sequence diff. How do we, yeah, I do here a sequence equal. But a sequence equal checks order as well. How do we not check the order? How do we ignore the order? What's that thing? Is that an intersect? Sequence equal is on. That an intersect produces a set intersection of two sequences by using the default equality comparer. Is that the intersection? Is that the correct one? Or is it the, what's the other one that I'm can't think of right now? Not intersect, but no, it's not the union. I'm not looking for the union, but for the except. The except. So intersect difference. Whose distinct elements that are also appear in the second. Distinct elements that also appear in the first. Okay, so those which are in both. And does it also reduce duplicates in case there was duplicates? Or I just order it just to have the sequence equal. I will, because if it wouldn't match, now I'm wondering about if it wouldn't match, then it could be that still the output is although the check here would be like failing because not because of the order but because of different strings. The output should actually have the very same thing. So I guess the move is to sort them. So I'll go ahead and say, actually this should only be done for this one. Where is the call? So I will add here an optional boolean, ignore order. And if we do not ignore the order, then the expected should be expected.order by static expected. Okay, that's a T. A T is not. To I collection. Okay, then we say to collection. Is to array a collection? Yes, it is. Okay. And also the actual. Actual is actual.order by static. Now this is what I meant earlier. I have to write like this func. I can't just say order by to array. I need to pass this func, which is static, like sorting it by itself. And with with .NET 7, we will be able to just write order. That's it, which is equivalent to that. And I guess faster because we don't have a lambda that we need to initialize. But also with C# 11, I think, or no, with an earlier version, I guess, especially static lambdas, they get cached. Okay, so it's a guess. Perhaps it's not about performance, but more about the syntax. Okay, now the test should be, oh no, I need to fix the compiler, yeah. So only for the properties. For the properties, I want to have, please mind the order. So we make this, perhaps I make two no, not sure, because this is a lot of we have 5 parameters. Ooh, this is too different. That's two different sequence diffs. Ignore order per default is true. That's bad. Per default it should be false actually. In my opinion. No. What about stream? No. What I'm searching for, like where you can pass in a boolean if you also want to dispose the nested stream. Is that true by default? Is that in file stream? I'm not wondering if like a default true boolean is good. Is this in file stream? Okay, it says owns handle. What's the default? True. Okay. Guess default trues are all right. Okay, so by default we ignore the order. No, actually, this is the other way around. Okay, per default we consider the order, we do a sequence equals. However, if we ignore the order, if we should ignore the order, now we order them. Okay, so this should now be correct. Oui, some Boolean logic. Oui. We have a failing test. And it fails because fails to compare two elements in the array, at least one object must implement comparable. We are passing in properties. We do select. Yes, I didn't apply the selector. Because I also pass in the selector. So I need to select as well. Okay, this is not the most beautiful implementation, but it should do the trick for now. Nah. Yeah. Okay, I need to rewrite this a little bit. So we will have, let's do it like this. Expected is, if we ignore the order, then we do this. Else we do just, yeah, we have this twice. that. Okay, and for the actual, if we ignore the order, we do this with the order by. Otherwise, without the order by. Okay, now we can get rid of these and we can use the actual here, here, and here. And this should do the trick now. Yes, okay. Let's run it 2-3 more times just to make sure that it's not flaky or anything. Okay. So what did we want to achieve actually? I digressed. Yes, so that we actually can pass in, that we can actually have an influence onto the compilation. And we do this via checking what we set in the down there in the in the properties. And now that I'm thinking about it, I also want to have this in the additional diagnostic as well, so that they are in sync. It should be the very same actually. Nah, it would be weird if it's different. Nah, I guess that's fine. Here we just have the name value, the hard-coded one. Okay. I guess. Let's have a look at the benchmark. So we do the ordering. Let's have a look at the test. Okay, so the compilation is definitely observed, because we have a test where if we don't set it, we have some default, but if we do set it, we explicit to C#1. Now we have C#1. Cool. I guess this completes. Yeah, we are asserting the C# compilation, and I guess the optional thing I'll not do. Perhaps we do this. We could always do this later for a future version. Let's have a brief look at this. I had a look at this last week. I can't entirely recall what this was exactly. So let's go to the benchmark and we have a brief look. We would actually set it here with the with analyzers. There's two overloads. One which takes the diagnostic options that we use already, and one which takes the compilation with analyzer options. And compilation with analyzer options also has the analyzer options, but additionally it would have some callback and it would have some flag indicating whether, okay, we could read currently on multiple threads, or could we actually set it? Perhaps we could even enforce it to be non-concurrent, but yeah, this is an optional feature. If somebody needs this, we can add it later on. And logging, yeah, nah. Report suppressed diagnostics. This could be interesting for implementing diagnostic suppressors. Okay, so I hope I can remember this in like 5-6 streams, whatever that is, in like a month, maybe 2. that we potentially need to use this with report suppressed diagnostics, whatever the default is. Doesn't say here. Okay, so I will not do the optional part, and we are pretty much in 2 hours already. I just want to do one tiny last little thing. See this in action. So perhaps 5 more minutes. Let's build an example. So what do we have here? We have a C# incremental generator, C# source generator. Let's add ourselves a C# diagnostic analyzer, and also a C# diagnostic analyzer benchmark type. I will heavily get inspired. I'll just copy the source generator in here. We'll change all the types, everything that needs to be changed later on. And for the analyzer, I will again go peek at the Roslyn SDK. So to have the same example, because people may be familiar with that diagnostic analyzer, so I guess it's nice to have a similar friend here. Let's copy, don't want to copy the name. Definitely copy the link to this file. Where do we put it? C bloop. Okay, let's just grab that. Okay. Title. We also need the resources, so let's jump to the resources. I don't want to do anything with resources, so I will just make this all strings. Okay, so the diagnostic ID is, I call it my 0001, or let's call it DA0001 for diagnostic analyzer. Nah, I want to call it my 0001. And the title, okay, let's get rid of this. So the title is analyzer title. Analyzer title is this string. Message format is this string, and description is this string. Perhaps I should check the license before I copy all over the, or copy all that code. MIT license. So okay, I will at the end need to attribute the repo. Well, I'm not sure if this is enough. I think I need some notice file in the repo, but yeah, we'll do this later. Here we add, actually, let's make sure to copy it correctly. Okay. And the category, what's the category? Naming. Okay, category is naming. All right. Make this internal. So we have this one rule. We don't analyze comments. We enable concurrency. We can get rid of, yeah, but I want to have here instead an unsafe cast. We know it's dead, so we can say unsafe.as okay. In my style we use the framework type for members. Okay. Now we have the example analyzer ready. Now let's go for the benchmark. So this is C#. Is that the same name? This is not all too great. Oh no, it's not the same name. Yes, it is. Benchmarks. Okay. I should name this type benchmarks. Then we don't have the name clash. Okay. So we will use the type. I guess we need a using now. We will be using F0 code analysis C# analyzer benchmarking. That's correct. Just to make sure this is the type that we wrote. There's the ordering. Yes, it is. We will be benchmarking this C# diagnostic analyzer. Okay. Now for the test. Let's unit test. Let's grab a couple of, let's do a string builder. Let's create a couple, a for loop. Let's create a couple of files. Let's say 100, 1000. How many types does an assembly have? 200 on average. I don't know. Maybe that's a fair assumption. To have like a meaningful test, meaningful example. And we append line string type is let's do some so that we have some syntax. Oops, why did needs to be a verbatim string, of course, interpolated verbatim string. And we that's the test, isn't it? No, that's from previously. I will have a namespace and the class. Let's make a file scope namespace. No, a block scope namespace, so that we can have multiple, so that we get some syntaxes here. Okay, so this is type name. Ooh, yes. Okay, so this will be an I, and this is type name I. Okay. And let's also add $200 more. So I need to append the type, of course, and let's append 200 more, but this time they are already all uppercase. So there is no diagnostic to be reported. I. Perhaps I should start here now at 200 and end at 400, that we continue counting. Okay, so we have 400 types. My code style would like to have a discard here. Okay. For example, yes, now we need some. This is from the other test. Okay, so we have a C# diagnostic analyzer initialization context. We add in the stores. No parse options, they can all be default. Then we actually invoke async. So this is task returning. And in the cleanup, we assume, okay, we assume that we have 200 diagnostics. Hui. So another for loop, 200. So this is a C# diagnostic analyzer inspection context. And this one has diagnostics. That's it. Let's initialize it. And add diagnostics.add a new ad hoc diagnostic with the markup key I. And let's also assert the message. Or let's actually assert what we have. Let's do a control dot to initialize create an object initializer. I don't want to assert all, but everything that we at least explicitly said. So let's assert the diagnostic ID. Let's assert the category. Let's assert the message. What is that again? Alt F1, the title. I want to assert the title. I want to assert the message, where the message should be. I believe I called it type name and then DI. Okay. We already have the category. We expect the severity to be a warning. We also have a description. Okay, the rest not so important. And then we would like to inspect, but it's also async. So we would like to return. Do we need to wait? Does it work if we return? Let's see. And let's actually make a mistake. Let's start counting at 1. And now let's go ahead and run this benchmark. .NET 1-C release. I think I also need to state the framework. Type namespace could not be found. Are you missing? I have a build error. Almost there. No, we don't. Okay. Why? Does it not build? It does. Did it not save? I obviously didn't save. Okay, and we want to run the diagnostic benchmark 0. And we do have an error, yes, because we expect 1, but it was 0 because I had a off by 1 issue. I will fix that. Okay. And now we create 200 diagnostics. We expect 200 diagnostics. Let's create one too many that we see it fail one more time with some message, hey. Yeah, so the expected count was 201, but we actually have 200. That's also cool. So, but now for the real one. Now let's run the benchmark and see how this one performs. I guess, yeah, as the result will not be super representative because I'm streaming on the side. But I don't know, I guess a couple of milliseconds. And here we do a 2-char array, so we do have an allocation. Diagnostic create also allocates. Yeah, but it shouldn't be too bad. And the result says, yeah, a couple of milliseconds, 2 megabytes of allocation. Well, it does one. It does create 200 diagnostics and it analyzes 400 types. So, okay. Well, perhaps there's a non-allocating way to do this check. Perhaps this one could be, but this would be now an optimization. The example shows perhaps there's a, because 2-char array, well, that's I would assume this allocates a char array. So I guess there could be a way to potentially be a span to do a non-allocating check. But yeah, I guess as an example, this is fine. And we have finished implementing the benchmarking types for diagnostic analyzers. What I will do in the week is a bit of cleanup, such as setting the version here to the lowest possible 0.0 and writing documentation and release notes and so on. But I will do this off stream because I'm now almost half an hour over. Yeah, we didn't do that, but we actually finished implementing benchmarking of analyzers. Woohoo! Which means next time we will start a fresh new topic. I will see to have these released, and then we go, yeah, with the next thing, with the code fixer. And let's see how long we need there. Perhaps 1, maybe 2 streams. And we will do this in a week. So this will be the 21st of August. Again, same time, 7 o'clock UTC, which is starting at 9 o'clock Central European time. And yeah, perhaps if you're in Vienna, we see each other at the meetup, potentially, on Tuesday, or perhaps you see the talk, the lightning talks via the live stream. And with that, thank you very much for staying a while and listening, and may Roslyn be with you all. Goodbye.